Using the zero exponents rule. Simplify each expression using the zero exponents rule. We know from the quotient rule that when we have an expression that has the same base in both the numerator and the denominator, we can subtract those exponents. So looking at example A, we can rewrite this as t to the 7 minus 7. I've got the same exact exponent in both the numerator and the denominator. When I have t to the 0 power, the zero exponents rule tells us that anything, no matter what the base is, when it's raised to the 0 power, is equal to 1. If I look back at my original problem here, it kind of makes sense that I've got the exact same thing in both the numerator and the denominator. So we are expecting that our overall answer should be 1 because the two items in numerator and denominator look identical. Let's move on to example B. I've got DE squared to the 11th power and DE squared to the 11th power. That 2 in the denominator is just kind of along for the ride. We'll leave it there for just a moment. So let's just leave the 2 down in the denominator and then write DE squared to the 11 minus 11. I'm just taking those two items that are raised to exponent and kind of putting them together. So that'll be 1/2 DE squared to the 0 power. Even though what's inside the parentheses looks a little bit more complicated than what we had in example A, anything that's raised to the 0 power is equal to 1. So I still have 1/2 here, and then this just becomes a 1 in the numerator. And so my overall answer here is 1/2. Looking at example C, I'm going to do a little bit of math before I think about the zero exponent rule. In the numerator, we've got the same base, so we can add the 4 plus the 2, which will give us w to the 6th over w to the 6th. Like we saw in example A, we have the exact same thing in the numerator and the denominator. We're expecting the answer to be 1, but let's show that using the zero exponents rule. This is w to the 6 minus 6, or w to the 0 power, which is equal to 1 like we expected. And then for example D, again, similar to what we just did there, we've got a little bit of math to do before we think about simplifying numerator and denominator. Let's rewrite this as t to the 3 plus 4 power, and then in the denominator we'll write this as t to the 2 plus 5 power. So it looks like I have t to the 7th over t to the 7th, which is t to the 7 minus 7, or t to the 0 power, which is 1 overall.